Me again. This is going to be lesson 2, inscribed angles and arcs. Yep, there's going to be some formulas you're going to need to memorize. Alright, so take a second and do this warm-up. Explain in detail what is wrong with the following statement. Alright, we're back. Here's my explanation. If the arc is named with 2 letters, it has to be a minor arc. And minor arcs always have a measure less than 180. If the measure of AC is 197, it cannot be a minor arc. If the measure is in fact 197, it should be named with 3 letters instead of just 2. I'm going to fix this. We're going to make this measure of arc A, B, C. Boom. Get some. So, we're going to identify and describe relationships among inscribed angles. Yes. Central question. How can I understand the relationship between inscribed angles, radii, and the chords? Click. An angle whose vertex is on a circle and whose legs are chords of the circle is called an inscribed angle. BAC is going to be an inscribed angle. BC will be the intercepted arc. Vertex. This is the vertex and it's on the circle. We're going to be seeing some key words here and you're going to need to catch on what's going on. Yeah, I did that. Super important. Something you're going to need to memorize. The measure of all inscribed angles is half the measure of the intercepted arc. Meaning BAC will be half BC. So going in is half. Going out will be times 2. Or I guess another way to look at it, instead of multiplying by a half, you're dividing by 2. Whichever way floats your boat. Kind of reminds you of those triangles from the last unit, doesn't it? So, take down the picture, write your formula. Let's check out an example. If I have 45 for xy, I need to find xvy. This guy. The vertex is on the circle, which means we just need to take half of 45. So 45 divided by 2. Let me use my calculator because I know that'll be a decimal. And we get 22.5 degrees. Skadoosh. Yes, it will be that easy. Find xy. We have the angle. The vertex is on the circle, so we just need to times 2. So 26 times 2 equals 26 times 2 equals 52. Yep, it's going to be that easy. Fun fact, if the measure BPC is 90 degrees, what is BC and BAC? Go ahead and give it some thought real quick. Alright, so we're back. So 90 is a central angle, which means this arc should be 90 degrees. But check it out, since they're sharing this angle here, that's kind of like this last example, so we take half to move back in. So if we take half of 90 to get down here, it should be shift 45. Now your brain's sure to be rolling. This is still pretty easy. What is Mr. C going to do to make this harder? Well, guess what? We're going to have circles with lines going every which way, and you're going to have to pull out every little property you can to figure out all the little angles. Moving on. We have cab. Look where cab's at. CAB. This guy's going to be 67.5. So to move it out here to this arc, we need to double it. So 67.5 times 2, we get, let me use my handy dandy calculator, 135. And look, this is a central angle. I know it's not told that P is the center. I'm telling you it's the center. So that means if this is 35, or 135, excuse me, this angle is going to be 135 degrees. So CPB, 135 degrees, BC arc, 135 degrees. And again, if you want to jot this down, you need to pause the video. Dry storage is full, go away. So this is a fun fact. That would be true of the inscribed angle, or that intercepts the semicircle. If SC is a semicircle, then what's the measure of SVC? Let's think about this. We have a semicircle. That's right, yeah, that should be 180 degrees over here. Let me just color it real quickly. That's 180 degrees. It's being inscribed here, which means if that's 180, well then, fun fact, this is 180. Oh my good grannies. Let's try that again. 180. Then this guy in here, half of 180 is gonna be 90 degrees. Do you think there's a property here about a inscribed semicircle? Yes. In fact, if I moved it up here and connect these legs, boop, I tried. This would be 90 degrees. Same thing here. This would be 90 degrees. If I went all the way down here, this would be 90 degrees. When you have an inscribed angle here that shares that semicircle, they're all going to be 90s. Hence, this kind of dabbles into those special triangles we talked about, and trig, and all that other fun stuff. So again, we emphasize now in another picture, if BDC is 180, that makes CPB 180 degrees. Oh, 180 degrees. And BOC again will be 90 degrees, no matter where you move that skeeter. I would move it to show you, but I'm scared that if I move this point, nothing else goes with it. Ah! Did you see that thing slide around? Moving on. That same idea is applied for this question. If two inscribed angles intercept the same arc, then they have the same measure. Find the measure of angle B and of CD. Well, we got 24 here. As you know, we got to times it by 2 to get out to the outside, which makes this 48 degrees. Okay. Well, this is an inscribed angle. It intercepts this arc. Well, then that means we'd have to divide by 2 to go back inside, right? Which makes this 24. That's right. No matter what vertex, or not vertex, but inscribed angle, they're all going to be 24 if they're sharing that arc. Even if I put it right there, right there, that too will be 24 degrees. Okay, very, very fun fact. Very, very good stuff here. If anything, could you argue that this looks like your eyeball? Do you think this has a lot to do with sight? Again, I'm trying to make a cross section of an eyeball, and and they have the nerve and your retina and all this other jazz. Yeah, I'm not a scientist. Leave me alone. Boop. AB is parallel to CD. Ooh. Okay, let's keep that in mind. What is the measure of AC? I'm just going to go ahead and pause the video because I believe you can get this right. I believe in you. Yes, you. Okay, we're back. That's absolutely right. Parallel lines, this is a transversal. That makes that 36. Vertex is on the circle. Double it to get outside. 36 times 2 is going to be 72. Measure that arc at 72 degrees. I know this looks like a headache, but just go ahead, take the time, copy it, and solve it. Trust me, you can do one thing at a time. Whew! Alright, we're back. Let me check it. Were we recording? Testing 1, 2, 1, 2, 3. Perfect. Sounds good to me. So P is the center. Then we have a diameter of AB. Perfect. Find measure 1. You got measure 1 here, and I need you to take a look at something. Do you see the inscribed angle here? They intercept this arc. That's 110. What's half of 110? That's right, 55. Angle 1 is going to be 55 degrees. We'll put that right there, right above it. 55 degrees. Let's look at angle 2. Skadoosh. That's right, y'all. So we got, do y'all see that? They share that same arc. I know what that answer is, 55 degrees. Ooh, I'm on fire. Number tree. Here's tree. Again, inscribed angle. I want this arc. Yeesh. I don't have a number here. I do have 130. I do know AB is the diameter, so this whole thing is 180. So real quickly, 180 minus 130, I get 50. This is 50 degrees. Go away. 50 degrees. Angle 3, half. That guy should be at 25 degrees right there. So 3 is 25 degrees. 4, look at that. They're sharing that arc we just solved. You see that? 4, sharing that arc we just solved. 25 degrees right there. Skadoosh. Look, see how easy it is? You're giving it too much worry. APC, let's see. A, P, C. But it says it's 70 degrees. Am I looking at this right? A, P, C. It says 70 degrees right in here. I must have left out a letter somewhere. Man, I'm losing my mind. I don't know. Put it there. ADB. Let's see. ADB. Its intercepted arc here is a semicircle, which means ADB should be 90 degrees. And then CAD. CAD. And look, it's intercepting this whole. I'll change it. I'll make it red. Its intercepted arc is all of this. So that means 110 plus 130. That's a plus sign. We get 240 degrees. Boom. So B needs important. I don't know why I even asked APC. What's going on here? Well, I've lost my mind. Moving on. So again, checking for understanding. Go ahead and pause the video and see if we can solve for these missing bits of information. I hate that curse. I hate that question mark. Boom, that's a better one. That's fly. So go ahead and copy, pause the video, and give it a second. I will play Jeopardy music as you think. Na 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 na. I'm tired of singing. Alright, here we go. Skadoosh. And there's your answers. Go back and check. Make sure you're looking at just the right spots. Okay? I think that'll do it for this lesson. Here's your homework. Again, I'll have a worksheet for you. What's the answer key? Alright, again, I'm going to say bye-bye. 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 Bye-bye.